Even though we do have a shortcut for the derivative, we have to know how to take the derivative with the limit definition. The first thing that we have to remember is what the limit definition is. The limit definition for the derivative is f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. So to apply this in our equation down here, that means that for the first part, we need to plug in x plus h for everywhere we see x. That means we're going to write it twice. So to take the derivative, we have f prime of x equals the limit. This is a limit until h goes away, so you must write the limit. F of x plus h means that we're plugging in, we have an x here, so we write x plus h instead, squared, plus another x, so we have plus x plus h. Minus f of x, so we just say minus our equation. We need to put parentheses here to make sure that we're going to distribute that negative. All over h. You must put the h every time or you will lose points. Don't lose points just because you didn't want to write something. Our next step is simplifying and moving everything around. So we still have a limit, so we still need to write the limit as h approaches 0 of 2 times x plus h squared is x squared plus 2xh plus h squared. And then we just have a plus x plus h. The negative does get distributed, so make sure that that negative goes to both things there. Minus 2x squared minus x all over h. Yes, continue writing the denominator. This is still a limit, so we still need the limit as h approaches 0. We're going to distribute this 2. Make sure that it goes to everything that you see. So we have 2x squared plus 4xh plus 2h squared. And then we have the rest, plus xh plus h minus 2x squared minus x all over h. Now is here where we combine our like terms and cancel things out. Positive x, negative x, gone and gone. Positive 2x squared, negative 2x squared, gone and gone. So we can rewrite this limit as it is still a limit because h is still there. The limit as h approaches 0 of 4x h plus 2h squared plus h. All of this is still over h. So our next step is to divide that h. It is still a limit even though we are canceling out the h. So we have the limit as x approaches 0, as h approaches 0. We cancel out the h here, 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 and here. Remember, h divided by h is 1. So we get 4x plus 2h plus 1. Don't forget that 1. Now that we take the limit, we take the 0 and plug it in for h. So all that's left is 4x plus 2 times 0 plus 1. So our derivative is 4x plus 1. That is how you use the limit definition of derivative to find a derivative. You must do this if this is asked of you.